1.8, perimeter, circumference, and area. This lesson should be pretty much of a review. You should have seen all of these formulas before. Our objective is to find the perimeter, also known as the circumference, if it's a circle, and area of basic shapes. Okay, a few definitions, some vocabulary for us here. The perimeter, known as capital P, of any polygon is the sum of the lengths of its sides. So, doesn't matter what the shape is, you just add up all of the sides. Area of a polygon is the number of square units it encloses. Now, we have formulas for all of these things, and these are also in your big packet on those back 2 pages. So, a square, now here we're told that perimeter is just 4 times S, or you can just add them all up. You can learn, some figures have specific formulas that you can use, and you can learn all of those and memorize all those and use them, or you can just stick with the basic idea that perimeter is just the sum of all of the sides. A square has 4 congruent sides. Look here in our diagram, we see 4 congruent sides. And so we could just do 4 times the length of one of those, or we can just add them all up. We are also told that area is the length of the side squared. Now, I prefer to look at area, and this is a good idea for you. Area is always base times height. So you notice here that a square and a rectangle have the same formula. It's the length of the base times the length of the height. And if you look at rectangle here, there is a special formula for perimeter, because in a rectangle, if we look at our diagram here, you see the opposite sides are congruent, and it has 2 pairs of opposite sides that are congruent. So we would do 2 times the height plus 2 times the base. Or again, you can just add up the length of all of the sides. But so for any rectangle, and we're going to find out that it's any parallelogram, we can just do base times height. Now, the reason that I like base times height is because if we look at a triangle here, how do you make a triangle? Well, if we take a square, I'll do it in a different color. If I take a square and I cut it in half, I have a triangle. So if you notice here, the area of a triangle is 1/2 base times height, which is why I'm telling you every figure we're going to do, and we're going to do more as the class goes on, every figure is some form of base times height. So thinking of area as base times height is going to benefit you instead of memorizing all of these different formulas. Now, if you notice here, height is right there, and you see that right angle. This is something we are going to use forever and always. Height is always measured perpendicular to the base. Perpendicular means 90 degrees, a right angle. That little mark right there means right angle. Height is always perpendicular to the base. And I'm sure you've run into triangles before this class, and you know that you have to measure from how tall the pointy part is down to the base, and it's always measured perpendicular. Even if you have to like extend the base over, so like a tilty triangle can be measured from the vertex to the base. Height is always perpendicular to the base. Now circles are special, and you will find, yes, circles are special. They think they're very special, and they are, but they think they're very special. Circles, we don't deal with base and height. We deal with radius and or diameter. And I'm sure that you know that radius is simply diameter divided by 2, or diameter is 2 times the radius. And we have a formula for circumference, which is just the perimeter of a circle, but because circles are special, they have their own vocabulary. Circumference is pi times the diameter, or 2 times pi times the radius. And you notice here those are exactly the same because diameter is just 2r. That 2r is the diameter. So it just depends on which measurement you have of which formula you use. Or you can pick one and always change your diameter to radius or radius to diameter. And you should know that the area of a circle is pi r squared. Alright. Units of measurement include inches, feet, yards, miles. So when we're measuring perimeter is a length. So we use perimeter or circumference because it's for circles. Inches, feet, yards, miles, centimeters, meters, all of those good measurements that you know. When we're measuring area, we use square units. Area is always squared. So things like inches squared, feet squared, yards squared, miles squared, centimeters squared, meters squared. Anytime you are doing an area, because we are multiplying 2 lengths, a base and a height, we get length squared. Let's look at our first example here. Oh, these are problems that I love, which means you'll probably see something like this on a test, so you need to understand it. So the first thing we do is we read very carefully. Botany Club members are designing a rectangular garden. We have a rectangle. The garden is a rectangle. So we're looking here. Here is our garden. The garden is a rectangle. And later on in the class, that will mean more to us. They plan to place an edging on the outside of the path. How much material will they need? Okay, well, if we look here, we have taken this diagram, and here's our edging. Edging goes around the outside. And we have taken our picture and our information, and we have redrawn it. You know, I love to draw and label everything. So we have our garden here. Garden's in the center. We have the measurements of our garden. Our garden is 16 feet wide and 22 feet tall, or long. So we have our rectangle in there. And then we are putting this edging around it, like a sidewalk or a cedar chip edging or something of that nature. And if we look at our diagram here, we see that we are told that that is 4 feet wide. So that's 4 feet wide here. That's 4 feet wide here, that's 4 feet wide here, and 4 feet wide here. So when we are looking for measurements, we want the measurements of the entire thing. We know that in between here, this is 16 feet, right? Because there's our garden, that's the width of our garden. And the walkway is 4 feet on this side and 4 feet on this side. So how do I find that entire length? Well, I'm going to add them all together. So this turns out to be 24 feet wide. And I'm going to do the same with this side. I know that my garden length here is 22 feet, but I have 4 feet of edging on this side of it and 4 feet of edging on this side of it, which is going to make the entire length 30 feet. So let's find out exactly what we're asked to do. How much edging material will you need? That's what they want. So we want to find the dimensions of the garden, including the path. So for the width of the garden is 24. The length of the garden is 30. I don't like using width and length. We want to find the perimeter of the garden, including the path. So I would just do perimeter equals 30 plus 24 plus 30 plus 24. Or you can use the fancy one for a rectangle, because you see 2 times 24 there and 2 times 30 there. And we get the perimeter is 108 feet. So to go around, to walk around all of these edges, we will have gone 108 feet. Alright, go ahead and pause the video and do the next problem. Okay, we are given a picture that is 5 inches by 7 inches, and we want to put a frame around it that is 1 inch, a 1 inch wide frame. Now if you think of a picture frame, you know that it goes on all sides. So the key to doing problems like this is drawing and labeling a picture. I very much love drawing and labeling, and you will too. So I drew my picture, and I labeled it 5 inches and 7 inches, and you do not have to draw these things to scale. In math, something is because you say it is. So that's why we label everything and do it accurately. So then I drew my frame around it, and I noted that it was 1 inch on all sides. And then I found my length of the outside. And I know that my picture on the inside, and then I add on 1 inch on both the left and right sides, or top and bottom sides, to get my measurements. So if I want to find the perimeter of the picture, I'm looking around this area, so I use my 5 by 7 measurements. If I want to find the perimeter of the frame, I'm looking at this, and so I use those new measurements. And notice that I didn't use any special formulas for rectangles. I just added up all my sides. And units on every answer, we are looking at length. Perimeter is a length, so it's just inches on both. Okay, good. Ooh, some good stuff here. Nope, that's supposed to be red. There we go. Good stuff. You name a circle with this symbol. That says circle. And then we use its center point, whatever letter that is its name. So a circle with center A is written like that. That is circle A. And circles involve pi, and you should know this. Pi and the symbol pi. You probably know that pi is the ratio of any circle's circumference to its diameter. But what is important here is that it is an irrational number. An irrational means non-terminating decimal. So some of you probably know pi further than others. Most of us know 3.14. A lot of us can do 3.14159. Some people can go to 100 or 1,000 decimal places. But the thing to remember is that it does not end. And so we can use 3.14, 7 over 22 if we need a fraction, and we can use the pi key on our calculator. You can also use 3.14159. The accuracy of pi is dependent upon the accuracy required in your problem. Okay? If we use a calculator, no, go back over there. If we use a calculator, we get an estimated answer. Okay? Because we are rounding our decimal. Not very neat over there. If we want an exact answer, we leave the result in terms of pi. So let's look here at a problem and see what that means. And you are going to have to read the instructions, and it will tell you, leave your answer in terms of pi, or an exact answer, or an accurate answer. And this will come up over and over again with us in geometry in various situations with other irrational numbers, like square roots. This will also come up in like science classes, where you need an exact answer or an estimated answer. Calculator gives you an estimate because you are rounding the decimal. All right, let's look at our first problem here. We are looking for the circumference of the circle in terms of pi. Oh, and to the nearest tenth. We want both. Alright, so circumference, we know that C is pi d, or 2 pi r. We look at our diagram. We are given this right here. We know that diameter is 15 inches. So we label everything. We are identifying everything we know from our diagram. Diagram is the first place you look. Alright, so we write our formula. C equals pi d. We substitute in 15 for d. And this is an exact answer. So we would say C equals 15 pi inches. That is an exact answer. Now, if we put that into our calculator, we get this decimal here. So then we say C equals, and we want to the nearest tenth, that's 1 decimal place, 47.1 inches. Both of these answers essentially say the same thing. One of them is accurate. 15 pi is an accurate answer, but you can't take that to the lumber store and say, I need 15 pi inches of wood. Instead, we would round that. This is a situational. Rounding is always done very last. Very, very, very last. So if we want it an estimated answer, if we want a decimal, we put it in our calculator, just 15 times pi, and we end up with 47.1. If we want to leave pi out of an equation, you just don't put it in your calculator. Let's look at the next problem. We have circle T on this problem. We are given the radius is 4 centimeters. So this time we're going to use circumference equals 2 pi r. So we simply substitute in the 4 for r, and then we do 2 times 4 in our calculator, and we get the circumference equals 8 pi centimeters. Right? We just put 2 times 4 in our calculator. We want our answer in terms of pi, so you just don't put it in your calculator. And then, if we want it to the nearest tenth, we put it in our calculator, and our circumference is 25.1, because we round here, 0.1327 just rounds to 0.1. centimeters. Again, both of these answers are the same thing, but one of them is accurate and one of them is an estimate. Okay, go ahead, pause the video, and do problem number 2 here. Alright, we were asked to find the circumference of a circle that has a radius of 24 meters, and we were told in terms of pi. So we identify the radius is 24 meters, so I'm going to use circumference equals 2 pi r. I substitute in. I want in terms of pi, so I only put 2 times 24 into my calculator. Oh, I'm writing down the wrong answer. 48. So I end up with 48 pi meters. 48 pi is a number. It's 48 times pi, which is a non-terminating decimal. Right? In the next problem, I'm asked for the circumference of a circle with a diameter of 24 meters, and this time I want it to the nearest tenth. So I identify diameter is 24 meters. I use my formula. Circumference is pi d. I substitute in my 24. I take 24 times pi in my calculator, and I get 75.39822. I want to the nearest tenth, so I'm rounding to this decimal place right here. That rounds up to 4. I get the circumference of that circle is 75.4 meters. Okay, so make sure you read your instructions carefully. Alright. Perimeter in the coordinate plane. Ooh, this is good stuff. We want to find what is the perimeter of, and look at how this is read, we're looking for perimeter of triangle EFG. So I'm finding points E, F, and G, and I want the perimeter of the triangle that creates, that those points create. Alright, so anytime I see coordinate plane, I know I need distance formula and midpoint formula. So which one of those are we going to use this time? Well, we're going to use distance formula. But let's look here. Let's start with segment EF here. EF goes from here to here. Now we could use the distance formula on that, but that is a vertical line. So I can use the absolute value of the difference. And I'm going from here to here, which is a value of 6 and a value of -2. So look, we do 6 minus -2. So this is 8 units long. And then I do the same thing here for segment FG. That is a horizontal line, so it's just a number line. I'm going from here to here, so I want my coordinates. This is 3 on the x-axis. This is -3 on the x-axis. Right? I'm just going from 3 to 3, and I just do 3 minus -3, and that's 6 units long. Now, the one that we have to really think about here is EG. EG is our diagonal one. So the first thing I'm going to do is I'm going to label my points x1, y1. Oh, I went the other direction. We did this x1, y1, x2, y2. It doesn't matter which order you put them in. All that matters is that you use them, is you label them. And then our distance formula says x2 minus x1 quantity squared, y2 minus y1 quantity squared, and we find that to be 10 units. We go through and do the math and find that to be 10 units. And then we simply add them all together, and the perimeter turns out to be, the perimeter of triangle EFG is 24 units long. So some things to remember here. if we have a horizontal and vertical lines, that the distance is the absolute value of x2 minus x1, and the distance is the absolute value of y2 minus y1. And then we use the distance formula here for diagonal lines. Alright, go ahead and pause the video and work out the next problem. Alright, we were told to graph the quadrilateral JKLM. We were given its vertices, so I graphed all my vertices, I connected them, I now have a quadrilateral. We want to know what is the perimeter, so I need the length of all of the sides. So the first thing I did was I identified vertical and horizontal sides because I know that they are the easy ones because I'm just using the absolute value of the difference. And so I started with side MJ, segment MJ, and I did 1 minus a -3, so those added together, and I found out this was 4 units long. And then I just did side JK, found out it was also 4 units long. Did side KL, found out it was 7 units long. And then when we get to the diagonal one, we know that we are going to have to use the distance formula. So I labeled my points x1, y1, x2, y2, and then I wrote out my formula, substituted in, and I found out that this is 5 units long. So the perimeter of quadrilateral JKLM is the sum of all of its sides, which turns out to be 20 units. Okay, not difficult, took a little work though. Alright. When you are finding, and you're using any formula, but here we're specifically talking about area, you need the same units for everything. Now, the thing about units, let's stop moving there, is you need to change them before you calculate. So you always check your units, and if your units don't match, you change them before you calculate. So here's a good example of how to change from feet to yards. You can go yards to feet. There are reference units in your big packet, and then we simply use our new units to find the area. Alright, next example. Finding the area of a circle. So it says, what is the area? So we're looking for area of circle K, and we want in terms of pi. So I look at my circle, and what do I know? I know that the diameter is 16 meters. I know that area requires radius, so that's half of the diameter, which is 8 meters. And then I write my formula, pi r squared. I substitute in r, 8. I square 8. This is simply 8 squared. Square is just you multiply it by itself. And the area of circle K is 64 pi meters squared. Alright, pause the video and do the next problem. Alright, we were given a circle with diameter 14 feet, so we know the radius is 7 feet, and then we're asked to find the area of the circle in terms of pi. So I simply write my formula, pi r squared, 7 squared is 49, the area of my circle in terms of pi is 49 pi feet squared. And then it tells us to use an approximation of pi. Well, if I use the pi key on my calculator, I get 153.93804, and then I round that to the nearest tenth. If you're not told, 1 or 2 decimal places is appropriate. Okay, so the area of my circle is 153.9 feet squared. And then I also did it using 3.14 because that is a very accepted value of pi. And I get 153.86, which again rounds to 153.9 feet squared. But look at the difference. We have a difference in our decimal here. So you and your neighbor can do the same problem and get different answers. And it's going to be a rounding error. And once again, what the accuracy of pi that you use and the number of decimal places that you round to is going to be completely dependent on the problem you're doing and the accuracy that is necessary for that problem. So note that this time we managed to get the same problems or the same answers, but one of them very easily could have been 0.8 and the other one 0.9. So when we're checking answers and doing our work in class, you and your neighbor can get different answers and still be right. They may be off by a little bit of a decimal. The bigger the number, the bigger the rounding error we're going to get. If our circle had a radius of 140 feet, that's going to be a rounding error 10 times larger. All right. And as promised, a new addition to our addition postulate family. And I told you these are always piece plus piece equals whole. And what do you suppose the area addition postulate does? It allows us to add areas. And so if we have an irregular shape, it says the area of a region is the sum. So we're going to add up all the areas of non-overlapping parts. So if we have an irregular figure, we can break it up here, notice, into 3 rectangles. And then we simply find the area of each, base times height. Notice how we redraw and label. So I redraw, I label everything. Area is just base times height. We find all of our areas and add them together. So go ahead, pause the video, and do the last problem here. Okay, we are given a non-regular figure here, and we want to know what the area of it is. So first thing I noticed is all these little congruent marks. So I know that all of those measure 4 feet. So that's the first thing I labeled on there is 4 feet for all of my congruent segments. All right? And then I said, well, you know what? I know how to do a rectangle and a triangle. So I broke this up into a rectangle. I redrew my rectangle. I labeled my base and my height. So my rectangle is right here. Height's 4 feet, base is 12 feet. That one's easy. I wrote my formula. Area of a rectangle is base times height, 48 feet squared. And then I did my triangle. Now my triangle, I know that this side over here is 4 feet tall because it's congruent to the side of my rectangle. Right? This and this are congruent. But I need to know how long this base is. Well, I know that the whole thing here is 12, and I know that this piece that's not attached to my triangle is 4, so 12 minus 4 is going to be 8 feet long, so my base is 8 feet long, and the area of a triangle is 1/2 base times height, and I know that height always has to be measured perpendicular to the base, and lucky for us, we have a little symbol showing a right angle. So we know that those are perpendicular. The definition of perpendicular is a right angle. Notice how we're using lots of pictures here. The definition of perpendicular is a right angle. So if two lines are perpendicular, you have a right angle. So lucky for us, our height and our base here are perpendicular to each other. Our two measurements are perpendicular, so we have height and base. Put them in the formula. Area of our triangle is 16 feet squared. And the area total, this is using our triangle, no, sorry, our area addition postulate says that the total area is the area of the rectangle plus the area of the triangle. I simply put those two in, and the total area of our figure covers 64 square feet. We would need 64 square feet of carpet to cover that space. All right, these are not bad. These should be just review. You just have to be careful. Make sure you draw, and label. And I hope you have figured it out by now. Geometry is easier in color. So good luck on these and have fun with your homework.